5.5, the law of sines. So we've got law of sines, law of cosines. Basically, when we're done with this, we'll have a quiz on this stuff. And then, depending, I may end up lumping this stuff in with the 2 sections of chapter 6 that we do. That's the final stuff of trig that we need, and do like a test on this. Normally, like, we test on all of chapter 5, and then I put 6 and 9 together and do a test. Like, they have a quiz on each and then a test on those together, but we might just hit all the trig together and then just do a quiz on chapter 9. TBD, but
Is 5.6 law of cosines?
yeah.
Did you post notes for that?
There probably aren't, because it's really just formulas, so they're probably, I think this was the last section of notes. And this is probably your last section of notes for the year, because I don't think I have notes for 6 or 9.
Okay.
But I have to look and see if I might have made ones for 9 last year. I don't remember. All right, so we have, my table's kind of like broken, but we have the different tables to determine how many triangles there are. I think I mentioned this, but obviously it was well over a week ago at this point. But this stuff is technically classified as a prerequisite for this class, according to AP, meaning that you should already know how to do this. So we're just taking time to refresh, because I know good and well you don't remember how to do it. You might remember the formula, but that's about it. So, anyways, so we're going to jump in with solving these triangles. So number 8, we've got angle B is 16 degrees, angle C is 103 degrees, and side C is 12. So I like to set up and write down all of the angles and all of the sides so that I can see what I need to fill in. If you want to do that instead of like copying the problem and then redoing it, you can kind of just set it up this way from the beginning if you would like to. So I'm going to need to solve for angle A, side A, and side B. A lot of times I do draw the triangle, more so when I'm doing the side angle problems. This one I'm given 2 angles, so this definitely can't be side angle. So I don't really need to write the triangle for this one, because there's only ever one triangle for anything other than side angle.
Angle, side, angle.
So this one's actually angle, side. Anyways, all that to say, circling back. What would be the absolute easiest thing to solve for in this triangle?
Finding the A degree.
Finding angle A, and how would I do that?
180 minus 16 minus 103.
Yep. And that is going to end up being 61 degrees.
Remind me again how you know the difference between side angle, and angle, side, and all.
Well, the way I would know the difference in those two is, for side angle, they have to give you 2 sides and 1 angle. For angle, side, they have to give you 2 angles and 1 side. But as far as like knowing the difference between like angle, side, angle, side, angle, side, side, and all of that, it's really just drawing the triangle and then looking at the things in order. So if I were going to draw this triangle here, I'm just going to say this is angle C. Obviously, this is not what this triangle would look like, because I have an obtuse angle here. But angle C, angle B, angle A, side C. So your side has to be opposite of its angle. So this would have to be side C over here. So basically, looking at it, I have angle, side. And it's always got to be like the things in order. So I can't be like, oh, well, this is angle, side, angle, because there's something else in between that I, so it's got to be this stuff in order. So angle, side for that. I don't know. Last year we had questions that asked us to say like which situation it was and how many triangles there were. Most of these, if they're asking you how many triangles, it's just stating how many triangles and not telling you like which situation. But if they're asking you that, in most cases, it's going to be side angle, meaning you have to find out using the table of stuff which one it is. So now I need to find the sides. I would always recommend that we use this information that was fully given to us and not stuff that I've solved for when possible, because that way I have a better chance of getting things right. And if I miss something, I'm not going to get like the whole problem wrong, because that's super annoying. So we'll start with side B. So I've got B over the sine of 16 is equal to 12 over the sine of 103. And then we just need to multiply. So B is equal to 12 sine of 16 over the sine of 103. And then you need to put that in your calculator. You are going to have to be in degree mode for these. So make sure you watch out for that.
.4. You stole my answer.
So we're going to just round to the whole number. So we're going to say 3. Now, it's not this section. I think it's the section for the law of cosines. They actually start you with numbers that are decimals. But we're just going to make it a general rule that if they give you stuff in whole numbers, we're going to leave it in whole numbers. If they give you stuff in decimals, we will go to the same amount of decimal places that they used if needed. So then I need to find A. So this is more so what I was talking about earlier. So when I'm finding A, I'm going to have A over the sine of 61 is equal to, I would refrain from using B because that's what I just solved for. If I mathematically type something in wrong and whatnot, I wouldn't want to use that, so I'm going to use C. So 12 over the sine of 103. Now your answer should basically be the same, but just to eliminate potential error. So we have 12 sine 61 over sine 103. Zach says it's 11. Which makes sense, okay? Whether or not you remember this all the way back from geometry or not, but the smallest angle has to have the smallest side, biggest angle has to have the biggest side, and so on and so forth. We also will get to some where, again, I think it's in the next section actually, where the values that they give you, yeah, because it would be for side, which is law of cosines. The values that they give you may not actually make a triangle because they may not be possible values for side lengths of a triangle. You don't have to worry about that in this section, but next section we will have to look at that as well. 12. Angle C is 103 degrees. Side B is 46, and side C is 61. So if I have a side and its respective angle, pretty much every time it's going to be side angle if the other one is a side. And then I have to be strategic about how I set this problem up. So I would like to draw a triangle for this one over here. And I'll have to check it. This could end up being a problem where there is no triangle, there's one triangle, there's two triangles. I have to do some stuff to figure that out. But just the setup of it, angle C goes here, side C goes over here, and then side B goes right there touching it. Okay. So at this point, I'm going to look at my table, which my table is kind of cut off, but This is the obtuse side over here. This is the acute side over here. So what kind of angle do I have? Obtuse. So that means I'm over here. Now, this is in terms of A and B. A is the one that had the given angle. So it was angle A, side A, and side B that were given to me. So in my case, I had angle C, side C, and side B. So I'm looking at C compared to B. So I'm saying, is C less than or equal to B, or is C greater than B? C is greater than B. So you might want to write this stuff down. Side angle, it's obtuse. The reason is that C is greater than B. And so then that tells me that I have one triangle. So I only have to solve one. So I'm going to set up the spot to write all of my stuff in over here. And then at this point I can start solving. You have to have at least one piece of information to be able to solve, so I can't solve anything for A, so the only option is for me to solve angle B. So sine of B over 46 is equal to sine 103 over 61. I'm going to multiply by 46, and I'm going to take the inverse sine of that whole thing. So I've got the inverse sine of 46 sine 103 all over 61. $47. Zach's being top secret. All right, how do I solve angle A then?
180 minus 103 minus 47.
Which is 30 degrees.
So that ends up being 30 degrees. And so then I can solve side A. Again, I would use the stuff from C as solving, because if I happen to have gotten angle B wrong, however, if I got angle B wrong, I probably also got angle A wrong. But I would recommend using the one that has all the stuff that was given to me. So I'm going to have A over the sine of 30 is equal to 61 over the sine of 103. Obviously, we know what the sine of 30 is from our unit circle, but I would usually just still type this whole thing in. So we'd have A is equal to 61 sine of 30 over the sine of 103.
40. That'd be 40.
Are you sure? That's not what I have, so I'm asking.
I use Pythagorean theorem.
You can't use Pythagorean theorem. It's not a right triangle. 31. That sounds right.
Are these just units, or are we given like a special?
These do not give us units. It's possible our book last year did give us units, and we were putting units on there for the side links, but the only ones that I can think of that possibly gave us units were the area problems, which I need to look to make sure I'm not missing something. Last year, if you remember, well, our Algebra 2 book, college algebra, I can't remember, but our Algebra 2 book, when we did the law of sines, there was area problems that went with law of sines because it used sine, and then there were area problems, Heron's area, that went with law of cosines because it was for a side problem. Our book, or this book, I should say, does all the area problems in the law of cosine section. So there will be area problems, but not with, at least I don't think that I see them in here. Make sure I'm not missing them, but I don't think I am. Nope. So they're in the other section, but those are the ones that could end up with units on them. The next ones just say to determine how many triangles there are, so 0, 1, or 2. So 14 Angle B is 82 degrees, side B is 17, and side C is 15. So these problems are ones where we aren't solving the triangle, we're purely just saying how many triangles there are. So first thing I'm going to look at is which situation do I have?
B is greater. Well, it's a cube. Yeah, cube.
So, well, first of all, it's a side-side angle, but it is acute. So then I'm going to go to the right side of my chart, and I'm going to look at those options. I'm looking at B compared to C instead of A compared to B, because that's what my chart is for side A, side B, and angle A. That's not the chart. So at this point, I'm going to look on this right-hand side over here, and I'm going to say, is B greater than C? Is B greater than C? Yes. So, I'm knocking things over. B is greater than C. And so then that means that we have one triangle.
This was side angle, right?
Yes. And acute. So yeah, the table, I would strongly encourage you memorize it. Algebra 2 did not listen to me. I told them, memorize this table or you're going to struggle on the quiz. Memorize this table, you're going to struggle on the test. And guess what they did?
Struggle.
They struggled on the test. They said, we have to memorize that whole table? Yes, I told you memorize table. Anyways, understand the concept of how it works. Memorize it for A and B and H. Go from there and then just know how to manipulate it based on the letters that you're given. It's not meant to be difficult, but you do have to memorize that or you're going to struggle. 16. Angle A is 73 degrees. Side A is 24. Side B is 28. So again, I've got side angle. Acute or obtuse?
Acute.
Acute, so I'm on the right side of my table. So then I'm looking at A compared to B. So first of all, is A greater than B?
No.
No, so then all the other things involve H. We haven't had H yet today. So H is equal to, in our situation, B sine A. Anytime we're solving for H, we want to go one decimal place past. H is the only thing that we're going to have decimal places for. Okay, so we have 28 sine of 73. Somebody can tell me what that's equal to with one decimal place.
26.7. Rounded 26.8. You just wanted to say 6.7.
So at this point, I'm going to look at the table and I'm going to say, okay, and now I'm looking at H compared to A. Is H greater than A?
H is greater than A.
So if H is greater than A, then I have no triangle. And that's just your answer for that. All that work for no triangle. It's even funnier when people solve no triangle problems. Gives me a solid laugh when I'm grading.
What's the dress code at your church?
Oh, it's relaxed.
Let's see.
I wear like a t-shirt.
Don't normally do odd, but number 17, they have the wrong answer in the answers in the book, so I just want to do this one. I don't know if, let me put it this way. My book has the wrong answer, and I'm assuming yours does as well. But I've had multiple times where I've assigned this problem, and then people come back and they're like, I just don't understand how this is the answer. This is what I got, and they're actually right. The book is wrong. So, angle C is 30 degrees. Side A is 18. Side C is 9. So, Side angle. Acute or obtuse?
Acute.
Acute. So then now I'm looking at, in this case, C compared to A. So is C greater than A?
No.
Nope. So then I need to find H. So H is equal to A sine C. So 18 sine 30. So H is equal to 9. That's just straight up. There's no decimal places.
H greater than C.
9's greater than 9. They're equal to each other. So H is equal to C because 9's equal to 9. And so this means one triangle. The book has somehow thought that 9 is less than 9, which is also less than 18, and so they say that it's two triangles. At least my book does. And that's obviously... I'm pretty confident that 9's equal to 9.
Can't pastors just start ChatGPT in their sermons now? That's like, that's scary. Yeah.
Alright, any questions on these?
It'd be good too.
No. Just like my paper.
AI doesn't always get its theology right.
Well, I got my research paper right.
They got my history right.
They got my history right, that's for sure.
That was sad.
Alright, 5 through 15 odd.
Ooh, my
Now, most of these, there's 4 that you're solving, and then the other ones are the ones where you're just telling how many there are.